Alright, let's go. Number 6, the arrow of time. Right now, take a glass of water and drop an ice cube into it. Watch it melt. You already know exactly what happens. The ice melts into the water. The cold spreads. Order dissolves into disorder. You have never once in your life watched a glass of water spontaneously freeze itself back into an ice cube. It has never happened. It will never happen. And yet, here is the nightmare hiding inside that simple glass of water. Every fundamental equation of physics is perfectly symmetrical in time. Newton's laws of motion work identically, whether time runs forward or backward. Quantum mechanics works forward and backward. Even Einstein's equations of general relativity make no distinction between the direction of time. If you filmed two particles colliding and played the footage in reverse, the physics would still be perfectly valid, perfectly legal, perfectly allowed by the laws of nature. So why does time only move in one direction? Why can you remember the past but not the future? Why does an egg smash on the floor and never unsmash? Why does everything in the universe drift relentlessly from order into chaos? What physicists call increasing entropy, if the laws of physics themselves don't actually demand it. The only accepted answer is the second law of thermodynamics: entropy always increases. But this law is statistical, not absolute. It describes what is overwhelmingly probable, not what is physically forbidden. Mathematically speaking, it is not impossible for your coffee to spontaneously reheat itself, or for broken glass to reassemble from the floor. It is just so staggeringly unlikely that it has never been observed in the history of the universe. But why was entropy so incredibly low at the very beginning? Why did the Big Bang start in such a perfectly ordered, low entropy state that allowed all of this, stars, planets' life, consciousness, to unwind over billions of years? We don't know. We have no physical law that explains why the universe started organized and is running down. We have no equation that tells us why you can remember breakfast but not dinner tomorrow. Time has a direction. Physics doesn't know why. Number 5, the dark matter shadow. Hold out your hand. Look at it. Every atom in those fingers, every proton in every nucleus, every electron in every shell, all of it, every gram of ordinary matter that has ever been observed, touched, weighed, or detected in the entire history of science, makes up less than 5% of the total mass energy of the universe. The rest is dark. In the 1970s, astronomer Vera Rubin discovered something that should have been impossible. She was measuring how fast stars in spiral galaxies orbit their galactic centers. According to Newtonian gravity, stars at the outer edges of a galaxy, far from most of its mass, should orbit slowly. Just like the outer planets of our solar system orbit the sun more slowly than the inner ones. But they didn't. Stars at the very edges of galaxies were orbiting just as fast as stars near the center, sometimes faster. The math said those galaxies should be flying apart. They should not exist. The only explanation that worked was invisible mass. Enormous halos of unseen matter surrounding every galaxy, providing the gravitational glue holding them together. We call it dark matter. It does not emit light. It does not absorb light. It does not interact with anything we know of except through gravity. And it outweighs all the stars, planets, gas, and dust in the visible universe by a ratio of roughly 5-to-1. We have been searching for dark matter particles for half a century. Underground detectors the size of buildings, cooled to within a fraction of absolute zero, waiting in complete silence for a dark matter particle to brush against a nucleus. Nothing. Particle colliders smashing protons together at 99.999% the speed of light, hunting for exotic particles in the debris. Nothing. Satellites scanning the sky for gamma rays that might signal dark matter annihilation. Nothing. Something invisible, massive, and completely unknown is everywhere around you right now. It is passing through your body, through this planet, through the entire galaxy. It has been here since the beginning of the universe, and we have not found a single direct trace of what it actually is. Number 4. The accelerating catastrophe. In 1929, Edwin Hubble discovered the universe is expanding. Galaxies are flying apart from each other in every direction. The natural assumption was obvious. The Big Bang launched everything outward, and gravity is slowing it down. Eventually, the expansion would decelerate, maybe stop, maybe reverse, pulling everything back into a big crunch. It was a clean, logical, beautiful story. In 1998, two independent teams of astronomers were measuring distant, exploding stars called Type Ia a supernovae to calculate the rate of this expected slowdown. What they found instead won them the Nobel Prize and broke cosmology entirely. The universe is not slowing down, it is accelerating. Galaxies are not just moving apart, they are moving apart faster and faster. Something is pushing outward against gravity, overpowering it, driving the universe into an ever faster expansion with no end in sight. Physicists call it dark energy. They have no idea what it is. It appears to be a property of empty space itself, a built-in outward pressure baked into the vacuum of the universe. And it makes up roughly 68% of everything that exists. The cosmological constant, Einstein's original mathematical term for the energy of empty space, which he himself called his greatest blunder, appears to be real after all. But when physicists try to calculate its value from first principles using quantum field theory, they get a number that is 10 to the 1/20th power larger than the observed value. That is a 1 followed by 120 zeros. It is the largest discrepancy between theory and observation in the history of science. Something is tearing the universe apart from the inside. We are riding the wave of it. We cannot see it, measure it directly, or explain it. And it will eventually drive every galaxy beyond our cosmic horizon, leaving our descendants, if any exist, in a universe of absolute, eternal darkness where no other galaxy is visible anywhere in the sky. The universe is ending, slowly, invisibly, and for reasons we fundamentally do not understand. Number 3. The Black Hole Confession. Stephen Hawking spent much of his career building one of the most disturbing ideas in the history of physics. In 1974, he proved mathematically that black holes are not actually black. Due to quantum effects near the event horizon, they very slowly radiate energy, lose mass, and over an incomprehensibly vast timescale, they evaporate completely. This radiation is now called Hawking radiation. It is elegant, it is beautiful, and it quietly destroys a fundamental law of physics. Here is the problem. Quantum mechanics contains an iron law: information is never destroyed. If you burn a book, the information contained in it isn't gone. In principle, it is encoded in the exact pattern of smoke, ash, heat, and radiation. The information is scrambled beyond any practical recovery, but the laws of physics say it is still there. This is called unitarity. It is one of the most foundational principles in all of quantum theory. But Hawking radiation carries no information about what fell into the black hole. When the black hole finishes evaporating and disappears, whatever fell in, matter, energy, the pattern of a star, the structure of a civilization, is simply gone, erased. The information has been destroyed. Quantum mechanics says that is impossible. General relativity says it happens. Both theories are correct. Both cannot be simultaneously right. This is the black hole information paradox. Hawking himself wrestled with it for decades. He proposed solutions, retracted them, died without a resolution. The world's greatest theoretical physicists, Hawking, Penrose, Susskind, Maldacena, have spent their careers locked in a battle over it. There are proposed solutions involving holographic principles, quantum entanglement, and Planck scale structures called firewalls at event horizons. None of them are universally accepted. None of them have been proven. Every time a black hole dies somewhere in this universe, the question burns like a fuse. Where did the information go? And what does it mean if it truly vanished? Number 2, the missing antimatter. Right now, you should not exist. When the Big Bang detonated 13.8 billion years ago, it did not create matter. It created matter and antimatter in perfectly equal quantities. Every proton born in the first microsecond had an antiproton born alongside it. Every electron had a positron twin. And when matter meets antimatter, they annihilate each other in a burst of pure energy, vanishing completely. Equal amounts of matter and antimatter should have produced a universe of pure radiation and absolutely nothing else. No atoms, no stars, no galaxies, no planets, no you. The math is clean and absolute. A universe born equal in matter and antimatter is a universe of nothing. And yet here we are. Here is the chair you are sitting in. Here is the planet beneath you. Here is an entire observable universe, stuffed with 100 billion galaxies, each containing hundreds of billions of stars, built entirely from matter, with essentially no antimatter anywhere, somewhere in the first seconds of the universe. One extra particle of matter was created for every 1 billion matter-antimatter pairs. Just one. A tiny, almost invisible imbalance. That infinitesimal asymmetry is the reason everything exists. Why? The standard model allows for a tiny violation of the symmetry between matter and antimatter called CP violation. But the violation it predicts is nowhere near large enough to explain the universe we see. Something produced a vastly greater imbalance than our best theory can account for. Some mechanism we have never identified, operating in conditions we have never replicated, tipped the scales just enough to save existence itself. We are the survivors of an asymmetry we cannot explain. Every atom in your body is a remnant of a cosmic annihilation event that almost erased everything, and we do not know why we survive. Number one, the universe's two speeds. The universe is expanding. We know this. We have known it for nearly a century. What we want to know, what has consumed cosmologists for decades, is exactly how fast. The number that describes this expansion rate is called the Hubble constant, and it is tearing cosmology apart from the inside. There are two completely independent ways to measure the Hubble constant. The first method uses the cosmic microwave background, the ancient afterglow of the Big Bang, to calculate the expansion rate from first principles based on the physics of the early universe. The second method uses distant pulsating stars and supernovae as cosmic measuring rods to directly observe how fast the universe is expanding today. Both methods are mature. Both methods have been refined over decades by thousands of researchers using the most advanced instruments ever built. Both methods are reliable, and they disagree. Not slightly, not within the margin of experimental error. They disagree by a statistically significant, stubbornly persistent, and deeply alarming margin that physicists call the Hubble tension. The early universe method gives one number. The direct observation method gives a number that is measurably, consistently, reproducibly larger. As observational precision has improved, the discrepancy has not disappeared. It has grown more certain. This means one of two things. Either both measurement methods have systematic errors that no one has identified despite decades of checking, which is deeply unlikely given how independent the methods are, or the standard model of cosmology is missing something. Some new physics is operating between the early universe and today, something that altered the expansion rate in ways our current equations do not account for. A new particle, a new force, a phase of dark energy that changed over time. The universe appears to be running at two different speeds simultaneously, and we cannot find the discrepancy that explains why.